Without any further words from me, may I introduce, please, Dr Samantha Organ from both the National Trust and the University of the West of England. Sam is going to be talking about something I think that's close to our heart because we never really understand what it is we're doing. That's pragmatic sustainability. Thank you.
Hi, everyone. Everyone had a good lunch? It was difficult after the lunch break because obviously then I've got to keep you awake, which is quite the challenge. I'm going to leave this quote on the screen for you to just read and reflect on. You don't need me to read it to you, but whilst you read it, I'm going to say that I'm going to be using notes so that I keep to time because you'll never get me off the stage otherwise. Just love a bit of a spotlight. Half time, half academic, half practitioner. The academic always comes out when I'm on the stage, unfortunately. So yeah, so if you just spend a couple of seconds. Okay.
Could you
yeah.
I think it's all turned on. So.
Is that better? Okay. So yeah, just spend a couple of seconds reading that with your powers of reading. Bear in mind that this was from 2022, so we haven't achieved the scale that we need. So effectively, the costs will continue spiraling and going up to reach the level we need. So I'm Dr Samantha Organ, as David said. I'm at the University of the West of England as an Associate Professor in Building Sustainability and also at the National Trust, although in 2 weeks' time I'm leaving the National Trust to move on. And in terms of pragmatic sustainability, as you'll all be aware, there's a huge amount to cover. So I'm a fast talker anyway, but strap yourselves in because I'm going to go really fast. I will also mention some things in passing and then a little bit more in detail. Just to keep you on your toes. And I'm also going to point some of you out. So hopefully it means during the break, the next break, you'll have a few more things to discuss. So we'll all be aware that the IPCC has made it very, very clear that climate-related risks for both human systems and nature are higher for 1.5 degrees Celsius pathway in comparison to the present, but actually lower than 2 degrees Celsius. We're unlikely to meet that 1.5 degrees now, but we urgently need to limit greenhouse gas emissions, including minimising cumulative emissions. Yet the UK is still not on track to meet our 2030 targets, according to a recent Climate Change Committee report. We know that our weather is becoming more severe, certainly seeing that in this country as well as abroad. And we're continuing to see the impact of anthropogenic emissions in relation to this. But whilst unavoidable, action is still needed to mitigate those climate change risks. We desperately need to put the brakes on our carbon emissions and upfront carbon. We know that of the emissions in the UK's built environment, that 48% of greenhouse gas emissions are from home energy use alone. Given that an estimated 80% of our homes will still be standing currently in the UK in 2050, action is urgently needed from our domestic property sector and reducing carbon emissions. This, of course, has other benefits too. So the UK Green Building Council has estimated that this could be about £56 billion worth of health benefits just from retrofitting 29 million homes, but only if we get it right. And we've seen already that there are some potential pitfalls, which we've explored already in today's session. But that's not the only thing to tackle, which is really exciting, isn't it? A wicked problem. The UK's non-domestic stock is estimated to contribute to 23% of operational emissions. Given that an estimated 70 to 80% of non-domestic property was constructed prior to 2000, this means that we need to retrofit to improve energy efficiency of these buildings by 2050. There's, of course, a commercial aspect to this. There's increasing demand of energy efficiency and carbon reduction amongst those who own, manage and finance our buildings, particularly on the commercial building front. Of course, it's not all about carbon and energy. Half the world's raw materials have been used to develop our built environment. construction is responsible for approximately 15% of fresh water use. There's a direct and indirect impact on biodiversity from construction, and we're not even going to mention the quantities of waste we send to landfill. And there are a huge number of different approaches we can adopt, and so it can feel quite overwhelming when we're approaching these sorts of areas. There are a couple of examples on the screen, taken from Historic England, Purcell, and JLL. Of course, there are other frameworks, such as PAS 2035, 2038, as well as others. I'd also add here that a people-first approach, as part of what Bill calls a proportionate retrofit strategy, is probably needed. You'll be thrilled to know that I'm not going to read all these bullet points out, death by bullet points and PowerPoint. But as you can see, there are many different sources of information to inform our understanding and knowledge, just as a starting point. These may include opportunities as well as restrictions, as well as just things to consider, but they are needed to guide our thought process and our decisions. In addition, it's worth noting that successful retrofits desperately need whole building thinking, and we've seen a little bit of that in today's earlier talks. There needs to be a change in people's behaviours, their attitudes, including expectations of comfort and what to invest in. This is likely to require engaging with stakeholders about comfort as well as discomfort, and perhaps what we need to invest in. How many of you have ever used EPCs? Raise of hands. Okay, and have you done that recently? Who's commissioned an EPC recently, or multiple EPCs? There must be more of you in here. Don't be shy. You can tell I've done some lecturing, can't you? Awful. So what I'd really like to know is how many of you use those to inform your retrofit decisions? Thank you for your honesty. There'll be plenty of other people in the room who do. Okay, so we know EPCs and their ratings can be inaccurate. Would you agree? Yeah. And recommendations, would you say they're suitable or unsuitable generally? Okay, so generally we're on the same page, which is good. I like this. So they tend to overestimate energy in older buildings and underestimate it in newer ones, with RDSAP typically assuming thermal performance to be poorer in our traditionally constructed domestic properties. Previous research has indicated that the same property with two different assessors can actually be two whole EPC bands apart. That's huge, and that also has implications if you're renting off your properties in terms of MEES. As we know, the EPC is being currently amended, which is good, and will be replaced in a few years by the home energy model. But we don't know what the impact is going to be on the ratings. Following Labour winning the election in July, MEES targets for domestic properties have been reaffirmed. Our domestic properties will need to achieve an EPC C by 2030, and commercial buildings will need to achieve a B by 2030. But EPCs can only tell us so much. For more accurate information, we can undertake measured performance and look at energy use. This could include in situ, U-value measurements, air tightness tests, and so on. There are also a huge number of guides and frameworks already available, with examples on the screen also representing different types of various outcomes. So it depends on what you're trying to achieve or what your client is looking for. There's also the upcoming net zero carbon building standard, which includes a heritage component, which Bill and Jill and myself, as well as others, have been involved in developing. Whereas other tools and frameworks, such as the CREM, help identify things such as the potential stranding point for our assets. So quite different. And there's a huge range of different outcomes that we could achieve. So it's really, really important to clarify this early with clients or building owners to understand what they're looking for, what they're desiring. They may not know, or they may think they know. And so sometimes it's about eliciting that from them to make sure that actually what you deliver is what they're looking for and what is helpful. It's also likely to impact on the approach you adopt and the measures you specify. It's also worth considering how success is going to be measured. So what are the agreed outcomes and what is that going to look like towards the end? Because actually you need to be able to demonstrate that success when you reach the end of a project. Given that around a fifth of the stock in England, the domestic stock in England, and around a third of the non-domestic stock were all constructed prior to 1919, that's a huge proportion of our stock here in the UK. So we need to consider how these buildings perform relative to their modern counterparts. We need to know the character and the behaviour of heritage buildings when undertaking retrofits. This is fundamentally different from our modern counterparts, but we need to understand it to help inform our decisions and avoid causing negative unintended consequences. So defects, the topic of this conference. To remedy those defects, that takes time to investigate and also find solutions and will cost money to resolve. Budgets and resources are quite often restricted and becoming more restricted as we see the cost of living bite in. Planning interventions over the longer term can be a practical approach, but should be carefully considered. This can help with practicalities such as finding cost efficiencies, limiting disruptions, and so on. I have the confession, I'm cheating very slightly with this photo. This is from my holiday last time I was in France last September. Yes, I took a picture of scaffolding on holiday. I'm not going to apologise for that. But scaffolding is a big cost to projects. When planning works over the longer period, try to look for cost efficiencies, such as whether you can group works together to limit the number of times you have to include scaffolding in your project, but also thinking about those other bigger outlays. Can you also try to reduce disruption to tenants or occupiers of those buildings just by grouping works together or phasing it? There can also be smaller, simple wins through optimizing the existing systems. So these can reduce the need for many other interventions, thus saving budget, but also avoiding and adding unnecessary carbon in terms of embodied carbon. Of course, there is something else. So in some portfolios, we might actually need to decide on whether to retain or sell properties with opportunities to reinvest any revenue from sales back into the wider portfolio. However, that strategy can come with some real challenges and needs to be very carefully approached. I often hear that budget won't stretch to energy performance. I hear it all the time, and it's often the first thing to get cut when we're trying to value engineer. But there are things we can do as building professionals which may not tip the dial for things like EPCs, but can still make a difference elsewhere in places such as comfort, for example. In addition to improving our building condition, making improvements to lighting, draft proofing can be really helpful, although consideration is needed still for ventilation. Other things to potentially look at include things like boiler flow temperature, where possible, loft and loft hatch insulation, and softer retrofit measures, such as heavy curtains and carpets with quality underlays. As part of the design and specification, again, taking a longer term approach is important. I'm talking not just about in relation to planning works, but also in relation to maintenance and lifespans of the products and measures being specified. Think about whether there are solutions and resources that could be sourced locally to try and limit embodied carbon. Although, let's all admit that at the moment that's quite challenging because it's not always a local solution that we can find. As we increase air tightness in our buildings, it's really important to consider the ventilation as mentioned, and not just by me in the earlier talks. What level of ventilation do we actually need? This may be higher for buildings with higher levels of relative humidity, for example. So we need to do it on a case-by-case basis. So determining the right level of ventilation is important. Is natural ventilation enough, or will mechanical ventilation still be needed? think also about the purpose of each measure. For example, a PV system. Is it being installed for heating, electricity, EV charging, something else, or a combination? If it's going to be used for something like a heat pump, when would you need the most energy in the year? Winter? When are you most likely to get typically the most electricity generated from a PV panel? Summer? So how about we think about the angle of our PV panel? Yes, we sacrifice some of the overall production of electricity, but in winter, maximizing the energy it can generate to help support the heat pump. So there are little things that we can think about to help determine how we specify and design. What about the maintenance requirements, and how easy is it to achieve those? Do we have to design anything else in? Whilst undertaking other planned works, can enabling works for future energy improvements be also undertaken? Are there any works planned which give rise to good opportunities for energy efficiency improvements? So effectively opportunity or trigger points. Consider the occupants and users in relation to behaviours and lifestyles as part of the design and specification. Can behavioural nudges be built in? And of course, consider the amount of embodied carbon that we're also adding to the existing building. Is it necessary? We also need suitably competent contractors and consultants, and I hear this a lot at the moment. Publications and discussions in industry have highlighted that the workforce is not widely up to speed with delivering these types of retrofits and interventions. Some organisations such as Grosvenor are helping to support their upskilling of their supply chain to help with this, whereas some contractors have noted a business opportunity of upskilling, but this can be at a significant cost to them. We need to consider not only how competent those we are contracting are, but if there are any opportunities to support upskilling and development of them. And this is because actually we can help avoid incorrect installation of measures, particularly when it comes to new products. We also need much greater integration and collaboration rather than working in silos. This is potentially challenging in an industry which has been highly fragmented. Correct commissioning is also an important consideration. I'm giving you a lot of different considerations here, so I apologise. But if it's done incorrectly, it can not only result in systems not operating as intended, but can give rise to frustrations, comfort issues, higher costs, and overall deter people from installing these sorts of products in the future. How do we know if an intervention has been successful? The motto of the RCS is est modus in rebus. If, like mine, your Latin is a tiny bit rusty, I'll translate it for you. There is measure in all things. Post-retrofit measurements provide an opportunity to identify whether a building or system is performing as expected after a retrofit, and if not, why and whether this can be remedied. There are a huge number of potential unintended consequences cited in the publications and witnessed by all of us in industry. We can avoid these through whole building thinking, using our professional knowledge, as well as using tools such as the STBA Responsible Retrofit Guidance Wheel. Importantly, just avoiding overcomplicating retrofits, measures and systems can really help avoid the issues. So keep it simple. The BRE's 2016 publication on solid wall insulation, a little bit old now, but still relevant, identified 29 potential unintended consequences. I've boiled these down to 8. So you've got typically moisture, air tightness in ventilation, impact on aesthetics, impact on property value, disturbance during ventilation installation, impact on maintenance, reduced daylighting, and potential impact on fire risk. How many of those can we design out? Would you say quite a few? I would say quite a few. just by thinking that through at the design stage of a retrofit can really help design out unintended consequences. How a building is operated impacts on emissions. Knowing how it is performing during operation is important, so measurement and monitoring has a role. And this can help with tweaks and adjustments to the systems to help performance. Green clauses for leases can be developed, and there is guidance out there on this, including Better Buildings Partnership, for example. But it's also worth noting that there's been some case law in this area, such as Clipper Logistics versus Scottish Equitable, in relation to adding green clauses to lease renewals. It's a bit of a minefield, so just watch out for those sorts of things. Innovations can be big or small, related to measures, finance, contractor agreements, supply chains, and so on. The example on your screen is a sun pipe, so not particularly innovative. I'm not going to apologise though. This measure hadn't actually been used in the portfolio prior to me installing it in 2017. Prior to 2017, this property was unlettable. It was pretty dark, lots of borrowed light, windows in internal walls and things. The staircase, which is what the sun pipe is over, was in total darkness, so you had to have an electric light on constantly. Since this was installed, the electric light is very rarely on, and the property hasn't been void since. So again, consider how you're going to measure success of an intervention. It could be something small like this or a wider project, but to be able to demonstrate that you've met the desired outcomes, you need the evidence. So I'm going to talk about a few examples now, 2 from the National Trust and 2 others. I'm also going to reference a couple of people in the room potentially, keeping on your toes. So I'd also like to shout out to Sam Walton and Rebecca Mitchell. If you put your hands up, please. They don't know I'm doing this. So in the breaks, go and talk to them, find out what they're working on, because some of the work they've done has been incredible, and I really encourage you to go and quiz them. No pressure, guys. Okay, so we've got a property on your left called the Red House at Dunham Massey. And this was occupied until just during COVID by some elderly tenants who passed away. The property required retrofit before releasing. The EPC increased because of that retrofit from a D to a C, so not a huge jump, but still a jump. And the measures included internal wall insulation, upgraded secondary glazing, draft proofing, loft insulation, a wood burning stove, and a new sewage treatment plant. The budget sadly couldn't stretch to an air source heat pump, so a gas combi boiler, quite unusual. Most of our properties are not on the gas network, but a gas combi boiler was installed with wall insulation. With the wall insulation, the team are hoping that if budget ever becomes available, then they can add a heat pump later. On your right, you've got Cinder Barrow Farm on the Sizer estate. This achieved an EPC A with internal wall insulation, insulation to the ceilings and floors, double glazed windows, wood burning stoves, an air source heat pump, which is supported by a PV array on the barn roof. Due to the available budget, neither property undertook in situ measurements, but we've all done things like this, where we've used the EPC to really guide some of our direction, as well as use our knowledge of the property, which was excellent from the local surveyors at the time. But had budget been available, wouldn't it be great to be able to do some before and after measurements? So this property is under the care of Gareth Fleming. So hand up, Gareth, please. And he's done a phenomenal job with this project. So he's far more knowledgeable about this than I am. So in the break, Gareth's your man. This particular Grosvenor property is on their Eton estate in Cheshire. Despite the EPC-D rating that they've achieved, the retrofit actually achieved a reduction in whole life carbon of 83%. It also halved the annual energy use, lowered the heating emissions by 94%, and achieved a LETI rating of A+. So quite phenomenal. The EPC was completed prior to the building regulations sign-off, I'm told. So they're hoping that they're going to redo that EPC to get a bit of a more accurate feel, but once the RD SAP has been updated, which I think is quite sensible. So in situ measurements were completed before and after the retrofit, with U-value pre-retrofit measured at 1.28, which is much lower than the 1.7 assumed by SAP. So is it worth doing the measurements? After the works, the U value was dropped to 0.51. Air tightness pre-retrofit was already relatively low, which is surprising given a Victorian building at 5.64. This reduced to 4.17 post-retrofit. The team investigated and decided that achieving a lower air tightness did not provide sufficient improvement to the whole life carbon to justify the gain in embodied carbon. A PHPP was used in advance of the retrofit as well to help understand and inform decisions. You'll see a couple of graphs on the slide, which formed part of the decision-making process about which measures to install, including whole life carbon calculations for the existing buildings. And that includes a retrofit with a gas boiler and a retrofit with an air source heat pump. Which one's lower? The graph on the left, let's say, might be easier. So the one with the air source heat pump, so much lower. So when they went to electrify the heat, that's where the big drop came. A matrix for the building elements was developed by the Grosvenor team and explored the various options for measures. They then assessed this against a range of parameters. Based on that, the specification, which is on your screen, was developed for the existing house and a new timber extension, the timber coming from the estate's existing sawmill. The building is also on the gas network, so very, very lucky for a rural estate. And it would have been cheaper and simpler just to use a combi boiler and radiators. But because this was a test project, the team had a look at the different options and assessed those. So their calculations showed, as we saw on the previous screen, that only when fossil fuel heating was replaced with electric heating that the biggest whole life carbon was achieved. Based on the carbon emission savings, the air source heat pump was installed. Due to the fabric improvements, the team are still confident, I would say, that the running costs won't be excessive. They've included an MVHR system, but they found that this complicated the roof insulation. There are many advantages for including an MVHR, but the team found that it wasn't particularly straightforward and it relied heavily on mechanical plant and ductwork, which may not be that practical for other properties. So for some of the other properties on the estate, they're exploring things such as passive ventilation, DMEV, humidity-controlled extractor fans, and so on. They also found that experienced installers and commissioners were needed for this system. The tenant was also provided with some training, and they're expecting to undertake the maintenance manually. So detailing on this project proved to be really complex. There appears to be a lack of industry knowledge and application. Given the consequences, as we've heard today, in the incorrect detailing, this could be actually quite concerning, the fact that the industry is not up to speed on this, as it could give rise to building defects and negative unintended consequences. It's really important to look at things such as how materials interact at key junctions, particularly given that thermal bridging can result in up to 60% in thermal loss. And therefore, this is an essential consideration. The devil, as they say, is in the detail. Also need to look at interstitial condensation and avoiding building in defects. EPDs, environmental product declarations, are not widely available, particularly for traditional materials, and therefore can mean difficulty in obtaining carbon data for measures we're installing. And calculation methods are still in need of refinement for consistent and accurate output. Here are some of the images of the almost finished property, care of Gareth. I'm going to skip on because I've got one more case to look through before I hand over. So I wanted to finish with this particular property. This is privately owned. This is Athelhampton, a privately owned Tudor estate down in Dorset, which has achieved operational net zero carbon. So actually, just let that sink in a minute. They've achieved operationally net zero carbon. This actually started with the owner, Giles Keating, teaching himself how to do a heat loss calculation, which when I found out that out, it blew my mind. The estate has a grade 1 Tudor house and a grade 2 holiday cottage. Interventions have saved around 100 tonnes of carbon annually. The property already had existing secondary glazing in their 1920s wing, as you do, and other interventions included some floor insulation in places. Oh, sorry. There you go. Should have said that I wasn't moving the slides on. But they also have 2 very large freestanding PV arrays in the grounds, 12 which feed 12 Tesla batteries. And where those batteries need topping up, they use a green tariff. There are some radiators across the estate, but there's a lot of underfloor heating, including in some of the older areas of the property. And they also repurposed the 1890s heating trenches, which were adapted to be supplied by the heat pumps, which I'll come on to in a minute. There's a weather compensator, and Nest thermostats have been installed throughout the property with the ability to read both relative humidity as well as temperature. There are 10 air source heat pumps. I have to say they were quieter than the fountain pump when I walked past them, which is quite surreal. There are also ground source heat pumps, with one serving the holiday cottage. Heat pumps all have buffer tanks, and the reported seasonal coefficient of performance currently is 3.5 to 4, which is excellent. I'm going to leave you, I started with a quote, so I'm going to leave you with a quote. I'll leave you to read it. But if you have any questions, then either ask the people I've directed you to or myself. And I'd just like to say, let's turn this super tanker around. Thank you.